Hello and welcome to AutoSharp. My name is Ryan McCaffery and I'm part of Team 9 along with Srivatsa Harish and Jeff Sen. This is our DP2 presentation. We're just going to focus on the concept generation of how we came up with ideas for our AutoSharp design and how we came to a final design for the product. Our mission statement is to design a device to facilitate the distribution of number 2 pencils during the exams. Before coming up with the concept generation for the AutoSharp, we first went back and looked at our DP1 to figure out why we wanted to make the pencil or pencil distributor and sharpener in the first place. So first thing we looked at was our mission statement, which stated why we wanted to make the pencil sharpener, which was we wanted to have something that could be used in colleges and high school environment to provide pencils when they are needed for testing environments or any time that one is needed for either a small price or just for free. Also, we went back and looked at our tournament style of how all the ideas we had were narrowed down into a few different ones which we chose from as our final design. Next, we looked at our customer needs, which were identified through interviews and surveys. First, we took the information that we gathered from customers and then interpreted that need into something that we could make for the AutoSharp itself. Then we ranked these as primary or secondary needs, and those were then prioritized into coming up with ideas for how the AutoSharp was going to function. The AutoSharp is tailored towards college students and high school students and taking exams. That was the main idea of our design for the product. And from this, we looked at interviews in the ideal college student customer profile and what they would want most in a pencil sharpener and getting pencils for exams. Through surveys and customer needs, we interpreted to create target specifications. So, from looking at comparative benchmarks, we were able to see what products on the market are used most for pencil sharpening in college and high school. We then looked at the specifications for this product, such as this X-Acto pencil sharpener, which is used widely through the United States. We would look at the amount of electricity used, the different sizes that could be used for the pencil sharpener, the quietness, durability of it, and then used our customer needs to see what people wanted most, and then incorporated those ideas into our design. After going through and reviewing all of our DP1 and why we wanted to do this product, we then functionally decomposed the product, which means we had our main function that we wanted our AutoSharp to do, and then based on that, the functions, user actions, and customer needs made that one function subdivide into different functions that we could break down even farther to design our product. So from our main function, which was to sharpen pencils and distribute them to students, we broke that down into how much energy we supplied and in what way, the user input, as in how the user will get the pencils from the pencil sharpener, and the output, how that pencil will come out of the pencil sharpener. From these three sub-functions of the main function, we broke them down even farther into, from energy, the AutoSharp itself could be powered by battery, could be crank powered, or could also be plugged into the wall by a power cord. The next sub-function that we divided even farther was the user input of how the user will get the pencil from the pencil sharpener. These could be done by swiping your hokey P for a small fee to get the pencil, or it could be button operated, so you push a button, no fee at all, and you'll receive a pencil sharpened, or it could also just drop it straight down whenever a pencil is needed. Output, how the user would retrieve their pencil from the pencil sharpener would be, it just drops straight down after it's sharpened. You can manually pull the pencil out of the pencil sharpener after it's been inserted, or it would have an Arduino motor that would be triggered from the button or the hokey P, which would rotate a platform and drop the pencil down to the output position. All right, the gallery method was used in order to provide helpful feedback from potential customers. But before we could get to the gallery method, we first had to come up with our concept generation ideas. So by doing this, the first thing that our group did, which is a very common way of coming up with ideas for a design, was the 635 method. 635 method was a method that we use, which is ideally for larger groups of people, but would work with our 3 as a group, where everybody has their own paper and comes up with multiple ideas, I think 3 ideas of what the pencil sharpener could be done, how those functions could be made. After coming up with your ideas, you would pass your paper around the table, so 5 times until everybody has done as many functions as they can think of. After that, you bring it all back together and look at all the brainstorms ideas, cut down the ideas that you did not like the most, and then narrow them down greatly until you have several ideas which you think could work for your final function. Another thing that we used to generate concept was the mind mapping, which you start with your central idea of sharpening pencils and distributing them at the center of the page. And this method creates a visual, which makes it easier to identify which ones you really want over others. After coming with your main idea, you expand on that for sub-ideas and then sub-ideas based on that until you fill up the whole page with ideas of how you could make the auto sharp, and then choose the best ones from that. And after using those 2 methods, we created a table of the ideas that we like the most and we think would be most appealing for the customers, for aesthetically in the auto sharp, and just would work best throughout the thing. And then this combination table you will see next in the gallery method that we actually created. So this is our gallery method. Here is the combination table, which we have our user input, energy output, energy usage, and our output, which we have all 3 ideas mentioned earlier. After putting that combination table in, we then drew out a visual of what we expected through each of these functions. Subfunction 1, 2, 3, and 4. Then from these subfunctions, we linked together multiple ideas to make one design. So we would link one subfunction of 1 to another subfunction of 2 to another subfunction of 3, and then we would draw the final design of those linked together ideas up here, and we could pick which one we thought would work the best. And then we presented this idea to our class to see what feedback they would have and which ideas they thought were the best. Based on their feedback and what we thought were best, we were able to choose which linking of ideas we thought would be the most ideal for the auto sharp. And then not only do we use that to choose our final design for the product, but we also used concept selection to also help us choose. These are the concept selection kind of things that we used. We screened it so that we compared each of the different output or inputs that the user would do towards the customer needs to see which would be most fitting. We compared them to the most simplistic idea, and then if it worked better, we would add a plus. If it worked better, we would use a minus. And coming out, the swipe turned out to be the most ideal for that screening of it. Then we ranked them. The ranking showed that each concept compared to the customer needs, the button option would be the most ideal for the overall concept of the auto sharp. From the screening and the scoring of our concepts, we came out with a design of the auto sharp that was incorporate the button for the input, the user input, along with the Arduino motor that will rotate the platform and distribute the pencil, and it will also be plugged into the wall, which will make for ideal use in the classroom. That is our DP2 presentation. Thank you for watching.